Carbohydrates. We need carbohydrates in our diet in order to give us the energy we need to complete daily activities. It is the energy source of our body. Types of carbohydrates. Monosaccharides. This is a basic unit of CHO as it only has one molecule, no bonds. It is a simple carbohydrate. Disaccharides. This is still a simple carbohydrate as it still only has two molecules with one bond so it can break down quickly. Polysaccharides. These type of carbohydrates can go right up to thousands of molecules, and these can be known as complex carbohydrates because they take ages to break down because there are so many bonds to break. Monosaccharides. Glucose occurs naturally. Fructose. These are the sweetest fruits and honey. Galactose does not form naturally, it forms milk sugar, lactose. All of them are broken down and used for energy metabolism. After absorption by small intestine, glucose can be used directly by the cell for energy, stored as glycogen in the muscles, converted to fat for energy storage. Disaccharides. These are still simple carbohydrates. There are two molecules which are combined together to make one. There can be sucrose, glucose plus fructose, most common, lactose, glucose plus galactose, and maltose, 2-glucose, e.g. sucrose and maltose. Polysaccharides. These are called complex carbohydrates because they are made up of 10 to many thousands of monosaccharides that are linked by glycosidic bonds. They are complex sugars, CHO. These take ages to break down because there are so many molecules. Therefore, athletes who need long bursts of energy, like for marathon runners, then need energy that will last them a long time. They will eat things like pasta because they contain lots of polysaccharides, which means their energy stores will last longer. For individuals who exercise regularly, their intake of carbohydrates in the daily diet should be 6% of their total daily calorie intake. With athletes who enjoy a lot of in heavy training, this number can increase to 70% of their total calorie intake. Carbohydrates are essentially in our daily diets because without enough of them, our bodies wouldn't have the energy to do anything. We can find them in cereals, dry fruits, potatoes, pasta, pizzas, salad dressing, and gummy sweets. In order for carbohydrates to have any effect on our bodies and our health, the key essential for carbohydrates is glucose because this is the building block of how carbohydrates are formed into energy for our body. This is the sugar within the carbohydrates which form our main energy source for our body.
Fats. What are the function of fats? Fats provide our bodies with energy, however, it is our secondary energy source because it works slower than CHO. However, it is our main source of energy when resting. It also keeps skin in good condition. It's also a good source to keep our bodies warm, and it protects vital organs, carries fat-soluble vitamins A, D, E and K, and needs help with absorption of the fats. As an extra energy source, fat is stored under the skin as adipose tissue. They're most likely found in foods that we all like crisps, biscuits, butter, sweets and chocolate. And within our daily calorie intake, it should be made up of 20 to 30% of fats. Because even though they all contain a lot of sugar and salt, we need a small amount of them in our diet to give us the backup energy store. How are they classified? There's saturated fats, and they're found in animal products such as milk, cheese, meats, cream and butter. They're generally found in a solid form at room temperature. Also, cholesterol content of these foods tend to be quite high. And there's unsaturated fats. They're found in foods like fish and plant products such as corn, nuts and soybeans. They're generally found in a liquid form at room temperature, and they also contain a lot of cod liver oil and sunflower oil.
Protein. What are the functions? Increase the strength of muscle fibres, repair damaged tissue from an injury, acts as an energy source when the body is depleted of all CHO and fats. That needs to build and maintain all cells within the body. How much of it do we need? We need between 10% to 35% of our daily calorie intake of protein to keep our bodies healthy. It is essential that children get the correct amount of protein in their diet because protein is essential in developing their bodies and helping with their growth. A men's intake of protein should be no higher than 85 grams, and for a woman it should be around 62 grams. When we need it. Protein in diet is essential when you when we're younger to help develop our bodies. When we're injured, to help them heal quicker. When someone is older, to help to build up their immune system, to keep their bodies away from any bad bacteria or illnesses, to build back up the immune system and fight away bacteria. How they're classified: amino acids, building blocks, protein, 20 different ones, 8 are essential. Any other class of nitrogenous organic compounds which have large molecules composed of one or more long chains of amino acids and are an essential part of all living organisms, especially as structural components of body tissues such as muscle, hair, etc., as enzymes and antibodies. They are used to build and repair the body, also used as an energy source when CHO is depleted. Source of protein: animal sources are general better. Eating excessive amounts can cause harm to the liver or kidney. What foods do we need to find protein in? Proteins mainly come from animals: meat, eggs, cheese, fish, milk and nuts.
Fibre is an important part of a healthy diet. A diet high in fibre has many benefits. It can help prevent heart disease, diabetes, weight gain and some cancers, and can also improve digestive health. However, many people don't get enough fibre. On average, most people in the UK get about 14 grams of fibre a day. You should aim for at least 18 grams a day. Fibre is only found in foods that come from plants. Foods such as meat, fish and dairy products don't contain fibre. There are two different types of fibre, soluble and insoluble. Each type of fibre helps your body in different ways, so a normal healthy diet should include both types. However, if you have a digestive disorder such as irritable bowel syndrome, you may need to modify the type and amount of fibre in your diet in accordance with your symptoms. Insoluble fibre. Insoluble fibre can't be digested. It passes through your gut without being broken down and helps other foods move through your digestive system more easily. Insoluble fibre keeps your bowels healthy and helps prevent digestive problems. If you have diarrhoea, you should limit the amount of insoluble fibre in your diet. Good sources of fibre, insoluble fibre include wholemeal bread, bran, cereals, nuts and seeds, except golden linseeds. Soluble fibre. Soluble fibre can be digested by your body and may help reduce the amount of cholesterol in your blood. If you have constipation, gradually increasing sources of soluble fibre such as fruit and vegetables, oats and golden linseeds can help soften your stools and make them easier to pass. Foods that contain soluble fibre include oats, barley and rye, fruits such as bananas and apples, root vegetables such as carrots and potatoes, and golden linseeds.
Vitamins. Vitamin A. Vitamin A helps strengthen immunity against infections. It also helps improve vision in dim light. Sources: cheese, eggs, low fat, spreads and yogurt. Amount 0.7 milligrams for men, 6.6 milligrams for women. Vitamin B. There are 7 types of vitamin B: B1, B2, B3, B6, pantothenic acid, fulvic acid, B12. B1 works with other B vitamins to help break down and release energy from food. Also, it keeps nerves and muscle tissues healthy. Sources: eggs, fruit and veg, and whole grain breads. Amounts 1 milligrams for men, 0.8 milligrams for women. B2. Its function is to keep skin, eyes and the nervous system healthy. It also helps the body release energy from carbs. Sources: milk, egg and rice. Amount 1.3 milligrams for men and 1.1 milligrams for women. B3. It helps produce energy from the foods we eat. It also keeps the nervous and digestive system healthy. Sources: meat, fish, wheat, flour and eggs. 17 milligrams for men and 13 milligrams for women. B6. B6 allows the body to use and store energy from protein and carbohydrates. B6 also helps hemoglobin. Sources: pork, bread, eggs and milk. 1.4 milligrams for men and 1.2 milligrams for women. Pantothenic acid allows the body to help release energy from the food we eat. Sources: chicken, beef, kidneys, potatoes. There is no specific amount as this vitamin will be in everyone's diet. Folic acid. The function of this is to help form red blood cells. It works with vitamin B12 to do this. Also helps reduce the risk of central nervous defects in unborn babies such as spina bifida. Sources: broccoli, sprouts, liver and spinach. 0.2 milligrams a day is recommended. Vitamin C. B12. B12's function is to help make red blood cells, release energy from the food we eat, and also to help process folic acid. Sources are cod, salmon, milk, cheese and egg. 0.0015 milligrams a day is recommended. Vitamin C. The function of vitamin C is to protect blood cells and keep them healthy. Also, vitamin C helps aid the healing of wounds. Sources: red and green peppers, strawberries, blackcurrants, broccoli and potatoes. Amount: 40 milligrams a day is recommended. Vitamin D. Vitamin D helps regulate the amount of calcium and phosphate in the body. Vitamin D also keeps bone and teeth healthy. Sources: oily fish such as salmon, sardines, mackerel, eggs and powdered milk. Everyone should be able to get enough vitamin D from a balanced diet, and also from being in the sun provides vitamin D. Vitamin E. The function of vitamin E is to maintain cell structure by protecting cell membranes. Sources: nuts, seeds, wheat and wheat germ, which is found in cereals as cereal products. Amount: 4 milligrams a day for men and 3 milligrams a day for women. Vitamin K. Vitamin K is needed for blood clotting, which means it helps wounds heal properly. Sources: broccoli, vegetable oils, cereals. The amount you need is 0.001 milligrams for every kilo of body weight you have. For example, a person who weighs 65 kilograms will need 0.065 milligrams a day. Vitamin classification. There are two types of vitamins: fat-soluble and water-soluble vitamins. Fat-soluble vitamins. The body stores vitamins in its cells. Consuming too much fat-soluble vitamins can cause toxicity within the body. Fat-soluble vitamins are vitamins A, D, E and K. Water-soluble vitamins are able to freely travel around the body and are not as likely to toxicate the body as fat-soluble vitamins, meaning you can intake more of these. Example of water-soluble vitamins are vitamins B1, B2, B3, pantothenic acid and folic acid. Minerals. Calcium. Function. The function of calcium is to build strong bones and teeth. It regulates muscles contractions, including the heartbeat. Also, calcium ensures the blood clots normally. Sources: dairy, soybeans, tofu and nuts. Amount: 700 milligrams a day. Iron. Function. The function of iron is to help make red blood cells. Sources: liver, beans, nut and dried fruit. Amount: men 8.7 milligrams a day, women 14.8 milligrams a day. Phosphorus. Function. The function of phosphorus is to help build strong bones and teeth. Also, phosphorus helps release energy from food. Sources: red meat, poultry, bread and rice. Amount: 550 milligrams a day. Potassium. Function. Potassium's role is to control the balance of fluid in the body and helps to lower blood pressure. Sources: pulses, nuts, milk, shellfish, beef and turkey. Amount: 3,500 milligrams a day. Mineral classification. Minerals are divided into two groups: macro and micro minerals. Macro minerals. These minerals are present in the body in large amounts. These minerals are calcium, phosphorus and sodium. Micro minerals. These minerals are present in small amounts in the body tissue. They are equally important as macro minerals. Examples of micro minerals are zinc, copper and iodine. Sodium. The function of sodium is to help to digest food. Sodium is a fluid that is vital in breaking down food in the stomach and intestines. Sources: cheese and tinned vegetables. Amount: you should eat no more than 2.4 grams of sodium a day. Sulfur: the function of sulfur is to help make tissue within the body, such as cartilage. Sources: eggs, garlic, walnuts, red meat and red peppers. Amounts: 133 milligrams a day.
There are two types of digestion in the body. There are chemical digestion and mechanical digestion. Chemical digestion, this involves enzymes and there are chemicals that break down the food inside the body. And mechanical digestion includes things like the teeth grinding the food and it's contracted to push the food down. The digestive system starts in the mouth. The technical term for the mouth is the buccal cavity. Once food has been put into the mouth, we use mechanical digestion, meaning we use our teeth to grind the food to partly break it down so it has room to go down the esophagus. Chemical digestion then happens because saliva is produced which helps to soften and make the food moist in order for it to pass down the esophagus easily. The tongue also plays a part in digesting the food because this helps mix the food and helps us swallow. Once the food has been chewed and swallowed, it enters the esophagus and this is a long tube that connects the mouth to the stomach. In order for the food to move down the esophagus, there is a muscular rhythm called peristalsis, which is a wave-like motion which helps the food flow down the tube. This movement by the esophagus means we can even eat upside down because it won't come back up because peristalsis is forcing down into the stomach. At rest, the esophagus closes and reopens when your brain thinks you're going to have food. That's why your belly rumbles when you're hungry, to give your brain a warning to tell you to eat something. The esophagus hasn't got any acid to protect the stomach, therefore that is why sometimes heartburn takes place. Also, amylase continues to break down the carbohydrates in the esophagus. In the mouth, the digestive juice is produced by the glands and they create saliva in the mouth which help the softening of the food. Your salivary glands produce saliva and saliva contains an enzyme called salivary amylase and this keeps the pH in the mouth basic. Salivary amylase will digest starch in the food in something called maltose, which later on gets digested into glucose in the small intestine. In the mouth, the food is mixed with saliva, which is now called bolus. The bolus is carried down the esophagus with the food using peristalsis. Peristalsis is the name for the muscular movement in the esophagus, which helps push the food down in the right direction. We also have a cardiac sphincter, which is there to stop regurgitation of the food down the esophagus, back up again. Therefore, sometimes when the food goes down the wrong hole, we choke and sometimes we are sick. Once the food has been forced down the esophagus, it ends up in the stomach, which is a large sac-like organ which holds acid in order to break down the food further. This acid is called gastric acid. The stomach continues to work off proper digestion, but no absorption of nutrients takes place in the stomach because the food particles are still too big. The only substance absorbed in the stomach is alcohol. That's why we're told to drink water when our bodies have consumed alcohol. It's meant to flush out the alcohol stored in the stomach. The stomach is made up of 3 layers of smooth muscles which help mix the food. Inside the stomach there are also parietal cells that line the inside of the stomach, which then release hydrochloric acid, which helps dissolve the food and get rid of any bacteria that might be present in the food. These cells can also release another digestive enzyme called pepsinogen, which is there to help protein break down. As the stomach is the first place where the bulk of the food is digested, it usually takes about 1 to 4 hours for it to be completely empty, depending on the amount of food eaten. If lots of carbohydrates are eaten, they tend to leave the stomach quickest because amylase has already been breaking them down in the esophagus. They're then followed by protein and then fats.
The small intestine is around 5 to 6 metres long and it's where the bulk of the absorption takes place. The small intestine is split up to 3 sections: the duodenum, the jejunum and the ileum.
In the upper 2/3 of the small intestine, based on help from the gallbladder, liver and pancreas. The movement of the broken down food particles move through the intestine based on gravity and the peristaltic movement of the smooth muscles on the small intestine wall. The duodenum is the first part of the small intestine when the milk-like substance enters it, and then it is mixed with 3 different liquids. Firstly, bile, which emulsifies fats to help with absorption. Then pancreatic juice from the pancreas, which secretes enzymes, and finally intestinal juice, which is secreted by the intestinal glands in the intestine. The pH level in the intestine increases because all three of these liquids are alkaline. Also, in the small intestine, there are very small things called villi and microvilli, which sit on the walls of the intestine and help aid peristaltic movement and push food along. The nutrients are then absorbed between the villi, and the waste particles are pushed down into the large intestine. Through the process of osmosis, the nutrients pass through the wall of the small intestine and into our blood supply with no energy needed. Once in the blood, the nutrients are transported to the liver via the hepatic portal vein, which then, once in the liver, is filtered, removing all toxins, and then starts to process the nutrients.
Liver. The liver is a large organ situated on top of and in front of the stomach. The function of the liver is to filter toxins from the blood. The liver produces a digestive juice called bile, which helps to break down fat. Bile also carries away waste from the liver. The enzyme is bile called lipase helps aid this. It then creates a substance called chyme. Liver. The liver is a large organ situated on top of and in front of the stomach. The function of the liver is to filter toxins from the blood. The liver produces a digestive juice called bile, which helps to break down fat. Bile also carries away waste from the liver. The enzyme is bile called lipase helps aid this. It then creates a substance called chyme. Pancreas. The pancreas is located below the stomach and above the intestines. It is a gland which produces enzymes which help with the digestion of carbohydrates, fat and proteins in the small intestine. The digestive juice that helps aid this is called pancreatic juice, which contains enzymes such as trypsinogen, chymotrypsinogen, elastase, carboxypeptidase, pancreatic lipase, nucleases and amylase. These enzymes help break down the food and then produce a substance called insulin, which helps to stop the fat as an energy source. Instead, it uses something called glucagon as an energy source. Gallbladder. The gallbladder is a small pear-shaped pouch in the upper right part of your abdomen, tummy. It stores bile, which is the digestive fluid produced by the liver that helps to break down fatty foods. Large intestine. The large intestine takes about 16 hours to finish in the digestion of the food. It removes water and any remaining absorbable nutrients from the food before sending the digestible matter to the rectum. The colon absorbs vitamins which are created by the colonic bacteria, such as vitamin K. Especially important as the daily ingestion of vitamin K is not normally enough to maintain adequate blood coagulation. Vitamin B12, thiamine and riboflavin. It also compacts feces and stores the fecal matter in the rectum until it can be discharged via the anus in defecation. The large intestine absorbs some of the products formed by the bacteria inhabiting this region. Undigested polysaccharides are metabolized to short-chain fatty acids by bacteria in the large intestine and absorbed by passive diffusion. The bicarbonate that the large intestine secretes helps to neutralize the increased acidity resulting from the formation of these fatty acids. Anus. The main function of the anus is to dispose of waste products out of the body. The anus is to eliminate the leftover waste solids in the body. The rectum acts as a temporary storage site for feces. As the rectal walls expand, it pushes down to the anus.